Hi, this is Kirchhoff Majumdar. Last day, or in our last video lecture, we have discussed the basics of the black body radiation. That is the introduction part of the black body radiation. The topic is same: Introduction to Quantum Mechanics. Learning objective is to acquire working knowledge of the quantum mechanics postulate on the physical system. Any heated body emits electromagnetic radiation. If the temperature of the body is increased, the wavelength of the emitted radiation decreases. Some laws related to the black body radiation. First, we will discuss Kirchhoff's law of heat radiation. The ratio of emissive power E lambda of a body to absorptive power for radiation of a given wavelength at a particular temperature is always constant. Mathematically, we can write E lambda by A lambda is a constant, say it is equal to K, where K is an arbitrary constant depending upon temperature. Now come to the construction of black body. For experimental purposes, a black body is made up by a hollow spherical copper enclosure with a small hole in its surface. This is the hole. This small hole is known as orifice. Inside of it is blackened by lamp black. Inside of it is blackened by lamp black. When any radiation enters the spherical cavity, it suffers multiple reflections at the inner surface. Characteristics of black body radiation. Number 1, energy density only depends upon the temperature of the enclosure. Number 2, radiations are isotropic and homogeneous in nature. Number 3, all bodies placed inside the enclosure also emit black body radiations. Comparison between thermal radiation and light rays. Thermal radiation and light rays both are electromagnetic waves. Number 1. Number 2, radiant heat like light rays travel in straight line with the speed of light, and both can travel in vacuum. The speed of light is 3 into 10 to the power 8 meter per second. Both of them obey laws of reflection and refraction.